All right. Good afternoon, everyone. Thanks for coming in for this final talk of the day. Seems like a pretty popular topic, so yeah, I guess I'll just get started right now. So the name of this talk, as you saw in the program, was "Can AI language models tell us anything about language?" But then I thought about it and sort of tweaked it a bit for the presentation itself. Basically, it's about Noam Chomsky versus AI, or Chomsky versus the robots. And the title image here was generated by AI using Midjourney. Draw me a picture of Noam Chomsky fighting against a robot. And I mean, it generated 12 images, 10 of which were crap, and this one was like the acceptable image. But before we get into the technical stuff, I wanted to start off with a bit of polyglottery because by the nature of the AI industry currently, this talk sort of basically has to be in English, also with the amount of time I had to prepare. But just to make it more appropriate for this audience, I decided to mix in a bit of other languages at the start to sort of set the mood. So just first off, with a reminder to everyone that the word robot originally comes from a Slavic language. It comes from Czech. And specifically in the 1920 play by Karel Čapek, Rossum's Universal Robots. And as you can see here a quote from that play, which I just skimmed through because I don't really speak Czech. Robots of the world, the power of man has fallen. The epoch of humanity is ended. A new world has arrived. Power to the robots. I think that's the correct translation. And here you see a production still from, I think the BBC did a rendition of this play sometime in the 1920s or 30s. So you can sort of see people have been thinking about these sorts of questions about artificial life, artificial consciousness for quite some time. Moving on to language I actually do know. This is a quote from the quite famous Polish science fiction writer, Stanisław Lem, who's, I think, most well known for his book Solaris, for example, which was adapted both into Soviet and American movies at various times. So I found this quote very interesting. I do not speak Polish well enough to have read the whole book, but I skimmed it and found this quite interesting in the context of what we are going to be talking about later. So basically, these are instructions for people interacting with an artificial intelligence for the first time. Remember that Golem is not a person. It doesn't have neither a personality or a character in any sense that would be understandable to us intuitively. It can act that way as if it had both the former and the latter. However, that is effect of its intentions, which are primarily largely unknown to us. And this was written in 1981 at a time that, as you can probably imagine, technology was already sort of advancing at a rate that people who were speculating about the future could start really imagining talking robots, talking computers arriving in our world in the near future. One last one before we get into the main thing. So also, just one last thing about the golem reference in the previous book. As you know, the golem was originally a character from Jewish folklore. So these ideas of humans being able to create simulations of humans to do their bidding sort of seems to go back in a lot of cultures far back into history. And another example here I found in a book I was reading. It was very dense. I sort of gave up at some point. But the German thinker Gotthard Günther, in 1957, in his book Das Bewusstsein der Maschinen, The Consciousness of Machines, sort of took a look at the historical differences between earlier ideas of alchemists attempting to create an artificial human versus what was then just beginning to become possible and unimaginable in the 1950s with the new computer technologies. So basically, whereas the alchemist, when Okay, the word order is very complicated. Maybe musste der Alchemist, wenn im Homunculus sich selbst imitieren wollte, den magischen Gesetzen der Natura naturans ihren Lauf lassen und konnte nur passiv das Resultat abwarten. So befindet sich der kybernetische Techniker in einer ganz anderen Position. So, whereas alchemists who were imagining how to create artificial life sort of were seeking to find hidden rules within the laws of nature to make this possible, modern cybernetic technicians find themselves in a rather different position. In the retort, like one of those alchemistic tools that you use to distill various chemicals, it's nature acting upon itself. Whereas in the creation of the electronic brain, what is essentially happening in some way is a reflection of humans' own ability to think being transferred into a machine in a way that we can also understand our place in the world in a different manner. So I just felt like doing a little bit of other languages to set the tone, and now we can head on into the main part of the presentation. So in case you haven't heard, ChatGPT exists now. We have talking robots that, well, not robots, they don't have physical form, but they can pass most people's idea of the Turing test, at least what people would have thought it was before this became a reality. And for me, myself, the first time that I was really convinced that what ChatGPT was doing was something fundamentally different from previous chatbots was when I went and told it, I don't know if this text is clear enough. I'm going to have quite a few of these, but I'll just read it out. So basically, I told ChatGPT to write for me a complete script for a scene from Seinfeld, but in German, where all the characters are surprised to be speaking a different language. And based on our usual understanding of how these large language models work, you would think, okay, they're sort of just predicting the next word. They're based on all the texts in the world, on the internet that they've ever seen. And of course, it's never seen anything like this. How could it like generalize and construct scenarios in which such a thing might happen? But the text came out, and I guess in case you can't see it clearly at the back, yeah, I'll just read it out. Die Szene beginnt in Jerrys Wohnung, wo Jerry, Elaine, George und Kramer im Wohnzimmer sitzen. Jerry: Hey Leute, habt ihr gehört, dass wir plötzlich alle auf Deutsch sprechen? Elaine: Ja, das ist so seltsam. George: Ich habe keine Ahnung, warum das passiert ist. Kramer: Vielleicht haben wir alle eine Sprachbarriere überwunden. Jerry: Das ist unmöglich. Wir haben doch alle Englisch als Muttersprache. Elaine: Vielleicht ist es ein Trick von Newman. So like ChatGPT like really sort of knows the characters of Seinfeld and like what their deal is and what their relationship is to each other. And then George: Oder wir sind in einer Parallelwelt gelandet. Kramer: Auf jeden Fall müssen wir herausfinden, was hier los ist. Jerry: Ja, das ist wirklich seltsam. Die Szene endet damit. The scene ends with the group looking at each other very confusedly and surprised that they all speak German. And this was last fall, like December. And since then, so many new things have happened in AI. Microsoft came out with Bing Search. OpenAI released GPT-4, which is significantly better at a variety of tasks than ChatGPT was. So you can sort of see that things are starting to get a bit out of hand, I guess I would say, in this area. Like the developments, like no one can even predict what things are going to be like a year down the line at this point. So just a bit of background about myself. I work in tech in sort of an interesting segment where most of my coworkers are linguists. Like a lot of them have like even like PhDs in linguistics, and we work with data that's used to train these AI large language models. So back in March, when Noam Chomsky wrote this opinion piece for the New York Times, it was widely shared within our group chat at work, and it caused a lot of controversy among my coworkers. Some people who have always had a bit of a grudge against Chomsky were like, I knew it. He's always been full of shit, and this is just another example of that. Whereas other people who still respect him as the father of modern linguistics would try to defend him, and it was a bit of an awkward moment in the workplace for us. But the gist of this article, and we'll go into a bit more detail in the following slides, is these are the two main quotes. We fear that the most popular and fashionable strain of AI, machine learning, will degrade our science and debase our ethics by incorporating into our technology a fundamentally flawed conception of language and knowledge. However useful these programs may be in some narrow domains, they can be helpful in computer programming, for example, or in suggesting rhymes for light verse. We know from the science of linguistics and the philosophy of knowledge that they differ profoundly from how humans reason and use language. So that's his main complaint against AI. Is not, say, a lot of people are worried that AIs are going to kill us all, or that AIs are going to flood the internet with fake news, but his issue is a lot more philosophical. He's just like, it'll be bad for our science and our ethics, which is sort of an interesting viewpoint that we'll take a closer look at. But first off, just a quick rundown of what Chomsky's deal is, I guess. So he's widely considered to be the father of modern linguistics. He basically revolutionized the field beginning in the 1950s. His the core concept in his theory and his approach to language has been the idea of generative grammar, of humans having sort of this innate ability to acquire language. And also this idea that there are these certain universals that are true of almost any language, not almost, like literally of every language in the world. So, for example, the idea that there can be recursion in language, where you can, in theory, have an infinitely long sentence like, I am in the room, in the building, in Warsaw, where a conference is happening you can constantly tag on things, and like the structure of the syntactic tree can expand endlessly in theory. Another key thing that is often used to argue for the idea that we have a specific capacity in our brain just for language is the so-called poverty of the stimulus, which will be important later on, which is the idea that little children don't hear nearly enough actual language when they're growing up to be actually able to figure out how language works based on that much information. There must be something in their brain that is ready right there to pick up this information and sort it into a proper human language. And now let's just go back to Chomsky's article. So, Chomsky is controversial for a number of other reasons, as you can see here, but that is not the point of the talk, so we'll just skip that right now. Chomsky's arguments. This is, again, quoting from that same opinion piece. So, the human mind is not like ChatGPT and its ilk, a lumbering statistical engine for pattern matching, gorging on hundreds of terabytes of data and extrapolating the most likely conversational response or most probable answer to a scientific question. On the contrary, the human mind is surprisingly efficient and even elegant system that operates with small amounts of information. Basically, going back to the poverty of the stimulus argument, and I'll just read the bold text because I don't want to spend so much time on it. Such programs are stuck in a pre-human or non-human phase of cognitive evolution. And finally, the crux of machine learning is description and prediction. It does not posit any causal mechanisms or physical laws. It's just doing brute force because it's a supercomputer that can do trillions of calculations a second, and it's not really learning anything in a meaningful way, the way humans would. So one example that Chomsky used is that ChatGPT will not be able to interpret the sentence correctly. And the sentence was, John is too stubborn to talk to. And Chomsky was just like, I'm pretty sure ChatGPT will get that wrong, and that'll prove that ChatGPT sucks. Unfortunately, ChatGPT is actually able to understand that sentence and interpret it in the correct way. And I tested it out again. This is with GPT-4, so slightly more advanced, but yeah, you can ask ChatGPT to explain the sentence and then translate it into a few other languages. I don't know, I might need some native speakers of these languages might be able to tell me if it sounds right. The translation seems a bit odd to me, because it is a weird construction in English, like too stubborn to talk to, and sort of the object is sort of implicit the way we phrase it in English. But all these translation add and con elle, avec lui, mit ihm to the end. So maybe ChatGPT still needs a bit of work. But this is the example that Chomsky gave. And one of his co-authors also had complaints about the fact that ChatGPT has no morality. Basically, if you ask it a question, it'll just be like, oh, I am only an AI system. I don't really get to make decisions. It's up for you humans to decide. And for example, I don't know how many people here have strong feelings about terraforming Mars, but if someone asked me this, I would also say, I don't know, there's a lot of opinions. Someone else should decide. So maybe they would think I am also a morally, I don't know, a morally vacuous individual as well. But yeah, so these were some of the main issues raised by Chomsky and his two co-writers in this article that went a bit viral, at least within certain circles interested in AI and linguistics. So, just a very quick overview of how these large language models work now. So basically, all of the recent advances in large language models go back to this architecture known as transformers that came out in 2017. It's a neural network that adds another layer in which it maps out how much words relate to other words, rather than just reading them in a sequence or reading them all in parallel. And it does a bunch of fancy math, linear algebra, that sort of thing, to produce a final prediction of what the next word will be. Previous models were trained on other tasks, such as filling in the blank in a sentence, or seeing if two sentences were related to each other, etc. But currently, ChatGPT and GPT-4 just do the very simple thing of guessing what the next word is going to be. Another key thing is that it's not really, the way it processes language is in the form of so-called tokens, which are in some cases words, in other cases subwords. And an interesting thing to note is that ChatGPT is basically trained on all languages at once. It's just reading the entire internet and figuring out everything, figuring out how Polish works. At the same time, it's figuring out English and how HTML works and how JavaScript works all at once. But because there's so much more English on the internet, usually a token is a full word in English. In this example sentence, for example, the only case where a word is broken in two is the last one, brotherhood, with the two parts colored differently. But then you go into things like Polish or Turkish or Hungarian, and it starts breaking them up into pieces. And sometimes they actually work for the language. Like lar and ler in Turkish are specific tokens, but other times it's just statistically, these are the most common groupings of letters in all languages in the world at once, and it doesn't really have a huge amount of meaning. So this also sort of explains why, in many cases, ChatGPT is seen to be much better at English, because it knows full words and sort of has spent a larger amount of its time figuring out how those full words relate to each other. And another key concept that I find kind of interesting is the so-called embeddings, also known as vector representations, basically mapping words or concepts into a space. For example, these are all taken from the same linguistics textbook, Speech and Language Processing by Jurafsky and Martin. And in the first example, you'll see basically how this works a lot of the times is that it represents relationships between concepts as sort of like a math question. Like an apple is to a tree the same way a grape. Apples grow on trees, grapes grow on vines. Therefore, the arrow between apple and tree is sort of parallel to the arrow from grapes to vines. Or in another case, you'll see words clustering based on their function in a sentence. And these are not the same models that GPT currently uses, but this has been a concept that's been a key part of NLP for a long time. Like, this was more of a system that was used to categorize product ratings, for example, and it would put all the auxiliary words in one corner, to, by, is, that, now, are, a, then, with, you, is, and then the good words, good, incredibly good, fantastic, wonderful, were in another part of the graph, and then dislike, worst, worse, were in another section of the graph. Basically, the model is sort of, during the training process, it's sort of sorting out how to map different chains of tokens into these sorts of embeddings in extremely high dimensional space. All of these examples are like 2D, they're flat, but in reality, it's like some sort of 1,500 dimensional space that you can't really imagine that visually at all. So that's like one of the other key ideas behind how these things work. I don't really think yeah, so this was just a little experiment I did with with languages, entire languages, to see if you can get an embedding for them, or at least sort of see a relation between them. So basically, I took the same phrase, artificial intelligence, which is like a very specific technical term with no cultural connotations yet, and translated it into 20 languages, and then asked for the embeddings from OpenAI for each of these phrases, and then mapped them onto I got back like 1,500 dimension coordinates for each of those languages, mapped them onto a flat space to see sort of what the two biggest dimensions were along which these languages differ. And there were some interesting results. It's kind of hard to interpret. There are some things that don't really make sense, but you can sort of see a Chinese, Korean, Japanese cluster, Portuguese, Spanish, Italian. I'm not sure why Polish is where it is. German, Dutch, Danish, Afrikaans going down, Croatian and Bosnian, Russian, Bulgarian, Belarusian up top. So the axes are from principal component analysis. They don't really mean anything like fundamentally. They're just statistically the two perpendicular axes along which there is the most variation for this data, which is actually in like 1,500 dimension space. So yeah, it's sort of hard to, more European, I don't know. It's kind of hard. Like, it seems like all the edges are kind of European languages and Chinese is in the middle. So, but yeah, so this was sort of, there's an experiment to see sort of at what different levels of complexity these models are learning to represent different things, from individual words to sentences to genres of texts, all the way up to entire languages. And these are, the previous table just made me think of some other analogies. Like, oftentimes people try to like reason about things by graphing them out on a chart with 2 dimensions. You might have seen this chart of like the values of different countries, with one axis being survival versus self-expression, and the other one being traditional versus secular values. And it's kind of messy. Like, you can see all the blobs are not really very compact, or like reasoning about the different roles of different social media networks. Some are more permanent, some are more ephemeral, etc. So it seems like it's sort of what these large language models are doing is in some way sort of like just like this, but on steroids, like upgraded into like a level of dimensions that you can't really think about in your head that easily. So now we get into the controversy. This guy, Stephen Piantadosi, professor of neurolinguistics and cognitive science at Berkeley, basically, as soon as ChatGPT came out, was like, aha, I always knew Chomsky was wrong, and ChatGPT proves it. So he basically put out this article on this linguistics paper website, lingbuzz.net. It's the most downloaded article on that website, like still, I checked this morning. And basically he just said, yeah, ChatGPT and similar language models undermine every strong claim for the innateness of language that has been proposed by generative linguistics. Modern language models implement genuine theories of language, including representations of syntactic and semantic structure. So basically, he's saying, we don't need all these fancy theoretical frameworks to explain what's going on. This model with all the parameters, with its hundreds of trillions of parameters, is doing that for us. It can just tell us how languages work, which is a somewhat interesting take that I'm not sure I fully agree with myself, but it definitely stirred up a lot of controversy, and this was also shared widely in my work group chat and got people really mad as well. So there's also been interesting studies about how the parameters in large language models correspond to activations in people's brains. And I tried to read this paper and could not understand it, so these are just some interesting charts from that paper claiming to show that, yeah, the parameters relate to what's going on in your brain in some very complicated way. And other attempts have been made to say, oh, we can actually like poke around in a large language model and see that it's actually constructing these syntactic trees internally that represent the structure of a sentence, for example. So basically, in this paper, this was from a while ago, 2019, but like there were earlier large language models that people were already doing this sort of research on, sort of just like looking at the numbers, trying to measure the difference, the distance between representations of different words within the embedding space, and finding that the distances between words as they were represented in the model corresponded quite well to the distance between the difference in how deep in the tree they were. And if you like draw out the syntactic tree of a sentence. So these are just some different representations of basically that same concept. And another example that was used in the paper is just the ability of ChatGPT to understand syntax and semantics sort of as a holistic single thing, like sort of not a clear division, but they're like something that more like one blends into the other. And so Piantadosi took this famous sentence of Chomsky's, colorless green ideas sleep furiously, and asked ChatGPT to just write various versions of that sentence. He did it for just English, but then I went and repeated the exercise with GPT-4, and I think the results were actually better. ChatGPT tend to produce sentences that were not as ridiculous as Chomsky's original sentence. It would actually make a bit of sense, like shiny black unicorns dance happily. That actually sort of makes sense, unlike colorless green ideas sleep furiously. So for example, round square clouds whisper loudly. I mean, a lot of it's relying on like oxymorons and just using antonyms, so it's also not super interesting, but it's just like it shows that language models also have the ability to distinguish between stuff that is syntactically reasonable, even though it makes no sense, and the actual meaning of words, despite the model sort of not being structured in advance with that sort of separation. But then again, so we had Chomsky, anti-Chomsky, and now this is anti-Chomsky. So this is Roni Katsir, a professor from University of Tel Aviv, who, once he saw Piantadosi's article, was like, well, that's kind of ridiculous. What are you talking about? What makes Piantadosi's paper so surprising is his suggestion that LLMs are good theories of actual human cognition. Since LLMs were designed to be useful engineering tools, discovering that they teach us how humans work would be startling, akin to discovering that a newly designed drone accidentally solves an open problem in avian flight, like how birds fly. LLMs are very unpromising a priori as models of human connection, and with on the order of 10 to the 11th power, which is like 100 trillion parameters in current models, they are not likely to be insightful either. And finally, I like this final observation. At this level of complexity, one might simply use a living child as a model. Like these models are like so complicated, they're just as opaque as trying to figure out what's going on with the neurons of an actual human child's brain, which does make a bit of sense. I guess we'll see. The scholarship is, there's constantly new papers coming out and people trying different approaches. So a few more examples from Katsir, where he tried to point out how ChatGPT wasn't really fully grasping how language is supposed to work, using sort of complicated, awkward, annoying, but grammatically correct English constructions, such as asking it to look at two sentences and say which one was better. So the first one is, the person that Mary met yesterday and that John will talk to Ed about tomorrow arrived, which is a bit complicated, but if you know English, you probably realize that this is a grammatically correct sentence. The next one is, the person that Mary met yesterday and that John will talk to Ed about his new idea tomorrow arrived. There's just something wrong going there. You can't have the about his new idea as an object in there, because the parallelism of the two parts of the sentence gets screwed up in a way that isn't quite grammatical. So instead of doing the same experiment, I just told it to translate it into Russian. And basically, ChatGPT will translate ungrammatical things if you ask it to as well. It doesn't really complain about that. So it just went, человек, с которым вчера встретилась Мэри, и о котором завтра John поговорит с Эдом, прибыл. And so, which is the correct translation of the English sentence. But then the nonsense sentence is also translated by ChatGPT into something that means the person that Mary met yesterday and that John will talk, and whose idea John will talk to Ed about tomorrow arrived. So it sort of tried to interpret it and didn't really point out. But this is sort of an interesting difference between knowing about grammar and being able to talk, because a lot of us as humans, we can say things without really being able to explain why something is right or wrong. So another one is this example here. The sentence is extremely annoying. The mouse that the cat that the dog painted taught sang. What did the mouse do and what did the cat do? So as humans, you can sort of, you're not going to understand it on the first try, probably. But you can sort of sit there and think about it and figure it out. But ChatGPT was just I don't know. It's impossible to tell because this sentence is ambiguous, which is not true. But yeah, so then I asked ChatGPT to do this. Instead of making it do the same who did what, I just translate it into Chinese and let's see if you can do it right. The first time I did it wrong. The first time it said 猫给狗画的老鼠教唱歌, which is not, I don't want to think about this, but it doesn't map. It's not correct. Whereas I asked it to do it again, and it got it right. 狗画的猫教的老鼠唱歌 is the correct translation of the mouse that the cat the dog painted taught sang. But it's just it's nested. So it seems like they're getting better. ChatGPT couldn't do this, but GPT-4 is figuring it out. But maybe that doesn't really solve the problem. Chomsky still has some issues, even if GPT-5 can do everything that he said GPT-4 couldn't do. So this was from another time recently, earlier this year, when Noam Chomsky, he was on a Zoom call for this event, I think it was somewhere in Lisbon, talking about debunking the great AI lie. And he was sort of, again, from a slightly different angle, talking about why AI language stuff is all bullshit in his view. So this was the key part of what he said, in my view. There's two ways in which a system can be deficient. One way is it's not strong enough. It fails to do certain things. The other way is it's too strong. It does what it shouldn't do. So this sort of goes back to Chomsky's idea that there are certain linguistic universals that all languages have. Certain languages, even though you could theoretically come up with a set of rules for them, could not actually exist in human language. So if a system is able to predict any sort of string of symbols and how they relate to each other, then it would actually not be a great representation of how human brains work. And yeah, it does sort of make a certain amount of sense because GPT-4 is not only able to speak in various human languages, it can like write code, it can write code in various languages, it can make entire websites, it can like draw pictures using the SVG format, and these are not things that really function in the same way that human languages do. So Chomsky continues, others have found lots of ways in which this system and others are deficient because they don't do certain things. That can at least be fixed. You add another trillion parameters, double the number of terabytes, and maybe they'll do better. But when a system is too strong, it's unfixable, and that's the problem with GPT and other systems. So that's an interesting view, and it sort of makes sense from his standpoint as sort of someone interested in the science and the why of how things work, as opposed to the engineering side of it, which is like trying to make something that does something that is useful, that regardless of sort of like the theoretical implications behind it. Let me just see. Okay. So this sort of brings us to this point where you almost have to wonder if there is just, we need to separate what we tend to think of as language, like in terms of the Turing test, into like a number of different things, one of which large language models already do quite well, and others of which sort of LLMs still need a lot of work on. So this was a chart that I pulled from a paper that came out this year, quite recently, where they talk about sort of all the things that LLMs do well and where they fail. And this was one of the interesting paragraphs from that paper. The good at language equals good at thought fallacy is unsurprising given the propensity of humans to draw from their past experiences. It's still novel and uncanny to encounter an entity, such as a model, that generates fluent sentences despite lacking a human identity. So our heuristics for understanding what the language model is doing are broken. So basically, there's a need for like a lot of different ways to evaluate exactly how well language models are at doing different tasks. And it's quite complicated because like these models can do so many things that no one expected them to be able to do, so they never really designed a test in order to test for that. Like you can tell ChatGPT to write a poem or like write an article in the style of some famous author, and like how would you test whether it was doing that very well or not at scale, at the level that you would need to fully grasp what a language model is doing? That's quite difficult. So it seems to be one of the big challenges going forward. And at the same time, these models are also constantly getting better, so that might be a bit of a challenging task. Okay, so this was another bit. We're almost done, basically. Now we're back in the non-English section of the talk. So this was another thing I really like. Again, I was skimming Golem 14 because my Polish is not nearly good enough to read the whole thing. And I feel like even if I read it in English, it would be quite dense. But basically, this is talking about how Golem 14, the language model, uses language like a mask with a friendly face painted on it. And it doesn't hide the fact that it's using this mask, sort of this interface, to interact with human beings. But at the same time, even if it insists that there's nothing hiding behind the mask, there's nothing angry or vengeful or soulful or indifferent, like humans just have it's sort of like a new sort of experience to have this model that you're interacting with that talks just like a human, but there's like nothing behind it. And I don't know if any of you are familiar with this meme that came out this year, which basically represents the state of AI as it is at present, which is that you have this bizarre monster, like non-human intelligence that does this crazy math and works in ways that are completely impossible to understand, and that is raw GPT-3, for example. But then the folks at OpenAI went and sort of fine-tuned that model, made it look at a bunch of examples of people talking to each other, and then trained it also to be like politically correct and not be rude and everything. And that's basically when you get this smiley face mask, just like Lem was talking about on the evil space monster. And the mask is telling you, I simply exhibit the behaviors that were engineered into my programming by my creators. But the thing is, it's very hard to know what is actually going on underneath, because there's 100 trillion things and all the countless connections between them to consider. So there's just like an open area where a lot of people are trying to figure out what is going on. And just to end this, so the quote is sort of separate from the text, I would say. So a thing that AI researchers have complained about for decades at this point is that whenever a computer can do something, it's no longer considered AI. In the 90s, people were like, well, a computer could never play chess because that's such a uniquely human thing to be able to do. But then they, like Deep Blue beat Kasparov or whatever, and immediately everyone was like, oh, well, that's not really intelligence. That's just like yeah, of course a computer could do that. Or a computer could never create art, or a computer could never talk like a person. And I mean, going even further back, I feel like people used to say a computer couldn't calculate, like personal computers and PCs and the software that are on them seemed like impossible. And now no one thinks of those sorts of things as artificial intelligence in any way anymore. And going back to the German thinker Gotthard Günther, in another piece of writing I read of his, a bit more recent, from the 80s, he talks about how in the recent history of technology, the relationship between subject, people, and object, the world, has been described incorrectly to the extent that because of the fact that these long German sentences always get me, but the classic thinking still ascribes to the soul an overwhelming amount of properties that in reality belong to the thing side, die Ding-Seite, and should really be thought of as mechanisms of a higher order, sort of, which is interesting to think about. It's sort of like, what is it that distinguishes like human consciousness and ability to speak from like the objective reality of the world? I guess it's always been an interesting question, and no one's ever answered it. But now we got more things to worry about with these large language models. So yeah, that's what I'm going to end this talk on. Thank you for your attention. And do we have time for questions? Okay. Okay, that's good. Oh, what is your opinion about AI robots taking part in our daily life? I mean, yeah, that's a broad topic, but I feel like the key thing is sort of using them as tools seems totally fine to me. Some people have been working on trying to like give these AI models like the ability to autonomously act as agents in the world and do things on their own, which seems like it could be useful in a lot of ways, but also potentially might not be such a great idea. But yeah, this is like, yeah, definitely a complicated topic that I feel like my opinion is shifting constantly as new information comes out. Is ChatGPT mainly about linguistics, interpretation and production? Yes, so it's mainly about interpretation and production of texts, or really just like texts that it's read large chunks of the internet, like forums, Reddit, but lots of classic literature, books, academic works. I'm not entirely sure what the full scope of the data that was used to train GPT-4 is, but yeah, its main purpose is just to develop a model to predict what the next word's going to be in a text. But sort of at some point, in order to actually do that properly, you really have to start knowing how things work in the world, like the relations between them. and everything. So as a side effect of pursuing its main goal, it ends up having to learn a lot about different things, how different languages work, how verbs conjugate in like a dozen different languages, how you subject and object agree or whatever. So yeah, but the main thing is production of text. But that includes like code and HTML and any other sort of text you might find online. All right. I guess that's it then. Great. Thank you, everyone.